Welcome to my channel. I'm Grace Tech. This is day 1 of 7 days to HTML confidence. Whether you are new to front-end development or brushing up on fundamentals, this series will help you write better, cleaner, and more semantic HTML. You will learn how HTML gives meaning to content, how to structure documents for real projects, and how to avoid mistakes that makes a site brittle. What is HTML? HTML stands for Hypertext Markup Language. It is not a programming language, it's a markup language, meaning it's used to label and structure content, not to perform logic or computation. It labels content, for example, headings, paragraphs, lists, images, and links. Browsers read these labels to build the document object model, which scripts and styles then act upon. This is the key difference between HTML and a programming language. Programming languages like JavaScript, Python, or C++ can make decisions, perform calculations, and execute logic. They can say, if the user clicks this button, run this function. HTML can't do that. It doesn't contain logic or interactivity. Instead, its role is purely structural. It defines the framework of a page so that other technologies can work with it. Think of HTML as the blueprint of a building. It tells you where the walls, doors, and windows go. CSS is the interior design, colors, textures, and layout. JavaScript is the electricity, plumbing, and moving parts that makes the space functional. Without HTML, there is no structure. Without CSS, it's plain and unstyled. Without JavaScript, it's static and non-interactive. Each plays a different role, but HTML is always the starting point. In 2025, with powerful JavaScript frameworks everywhere, you might wonder, why still care about HTML? Because every framework, every component, every web application still starts with HTML. It's a language of structure, accessibility, and meaning on the web. Get it right and everything else builds smoothly on top. What you need to write HTML is surprisingly simple. No expensive software, no complicated installations. In fact, you probably already have the essentials on your computer right now. 1. A text editor. A text editor is where you write your HTML code. You can technically use something as basic as Notepad on Windows or TextEdit on Mac. But for a smoother experience, I recommend a code editor built for web development. Popular free options include Visual Studio Code. It's powerful and full of extensions for HTML, CSS, and JavaScript. Sublime Text. It's lightweight, fast, and distraction-free. Atom. It's open source and highly customizable. A good editor gives you syntax highlighting, auto-completion, and quick error spotting, which makes learning HTML much more easier. 2. A web browser. You need a web browser to view your HTML pages. Chrome, Firefox, Edge, or Safari will all work just fine. Browsers read your HTML, interpret the tags, and display the page. They also have developer tools. Just press F12 or right-click and choose Inspect to view your page's structure and test changes instantly. 3. A folder to organize your project. Even small projects benefit from staying organized. Keep your HTML files, images, and style sheets together in a clearly named folder. This makes linking files much easier later on. 4. Local server setup. You can open HTML files directly in your browser, but tools like the Live Server extension in Visual Studio Code automatically refresh your page as you save changes, saving you time while you build. 5. Version control. If you want to track changes or work with others, version control systems like Git, along with platforms like GitHub, make collaboration and backups easy. So, at minimum, all you need today is a text editor and a browser. As we progress, you can add more tools to speed up your workflow and level up your skills. A modern web page isn't just a bunch of random tags. It follows a strict structure. At the top is a doc-type HTML tag declaration. It tells the browser to render the page in standard mode. Then come the root HTML tag elements, wrapping the entire document. Inside it, we have the head tag element, which contains the metadata, links, and scripts, followed by the body tag element, which holds all the visible content. This structure is consistent across every well-built web page on the internet. Here's a clean HTML5 boilerplate. It's the starting point for any serious web project. Let's go through it line by line. We have the meta charset tag, which ensures the document uses UTF-8, supporting nearly every character. The viewport meta tag is crucial for mobile responsiveness. And then we have our title tag, which is going to display what our website is called, and it's going to be right there in the browser at the top. And inside the body tag, you can begin inserting headings, paragraphs, images, and HTML is made of elements. An element has an opening tag, content, and a closing tag. Elements can contain other elements, which is called nesting. Proper nesting makes a valid DOM and predictable rendering. Common mistake: incorrect nesting. Never overlap tags incorrectly, e.g., don't open a p tag, then open a div tag, then close with a p tag. Browsers attempt to correct it, but the result is unpredictable. One of the first layout concepts you need to understand in HTML is the difference between block level elements and inline elements. Block level elements are like big containers. They always start on a new line and they automatically stretch to take up the entire width available, even if the content inside is small. Imagine them as big boxes stacked on top of each other vertically, like paragraphs, headings, or sections of a page. Common examples are div tag, p tag, h1 tag to h6, section, and articles. They each start on a different line. Inline elements, on the other hand, don't break the flow of text. They sit inside a line alongside other inline elements, only taking up as much space as they need. Think of them as individual words or labels that fit neatly in a sentence. Examples include head tags for links, span for inline styling, strong for bold text, and hem tag for emphasis. Why does this matter? Because the type of element affects how it behaves when you style it with CSS. A block level element will respect width, height, padding, and margin in all directions, but an inline element ignores width and height by default. It only responds to horizontal padding and margins. For example, if you place a strong tag inside a paragraph, it will just bold the text and flow within the sentence. But if you change it to display of block in CSS, it will suddenly jump to its own line and act like a box. Understanding this difference is critical because when you start building layouts, you need to know which elements will stack vertically, which will sit side by side, and how to switch between those behaviors with CSS. This knowledge makes positioning and designing pages much more predictable and professional. In HTML, not all tags are created equal when it comes to meaning. This is where the concept of semantic HTML comes in. A semantic element is a tag whose name clearly describes its role and process in the content. For example, a header tag represents the top section of a page or section. A nav tag represents the navigation links. Article tag represents a self-contained piece of content, and footer tag represents the bottom section. When you use semantic tags, you are not just telling the browser how to display something, you are telling it what that something is. This makes your HTML much more meaningful to both humans and machines. Now, let's compare this to non-semantic HTML. Non-semantic tags like div tag and span tag. They tell the browser nothing about their content. They are generic containers, just empty boxes for grouping and styling. A div tag could be a header, a navigation bar, a sidebar, or literally anything. You only know its purpose if the developer adds extra clues, like a class or ID attributes. For example, you could write a div tag with a class of header, and yes, a human reading your code might guess it's a page's header, but to a search engine or a screen reader, it's just a generic box. If you instead wrote header tag, the tag itself communicates meaning instantly, no guessing required. Why does this matter? There are 4 big reasons. 1. Accessibility. Assistive technologies like screen readers can navigate a page much more efficiently if they understand the structure. 2. Search engine optimization. Search engines look at your page structure to determine what's important. Semantic tags help them better index your content. 3. Maintainability. When your HTML reflects the logical structure of the content, it's easier for you or another developer to understand and update later. 4. Future-proofing. Web standards evolve, but semantic HTML stays more consistent because it's based on meaning, not visual appearance. The generic rule is, if a semantic tag exists for your content rule, use it. Only fall back to div tag or span tag when there is no semantic tag that fits. We've come to the end of day 1 of 7 days to HTML confidence. In day 2, we will dive deeper into text formatting, links, and images, the building blocks that brings your content to life. Make sure to subscribe so you don't miss it. I'll see you in the next lesson. Bye!